In a sample of Wall Street analysts, 44% incorrectly forecasted earnings in the high-tech industry in a recent year. A. Which part of the study represents descriptive statistics? B. Use inferential statistics to draw a conclusion from the study. Part A. Descriptive statistics represented in the study include the statement, in a sample of Wall Street analysts, 44% incorrectly forecasted earnings. Part B. One possible conclusion you can draw from the study using inferential statistics is that it is difficult to forecast stock market earnings in the high-tech industry. Use a line plot to organize the following test scores. Which score occurs with the greatest frequency? Begin by scanning the data to find the least and greatest numbers. For this data set, the least number is 61 and the greatest is 95. Next, draw a portion of the real number line that includes the interval 61 to 95. To create a line plot, start with the first number, 68, and enter a dot above 68 on the number line. Continue recording dots for the numbers in the list until you obtain the line plot shown. From the line plot, you see that 82 occurs with the greatest frequency. In example 3, how many days was a high temperature less than 80 degrees Fahrenheit? Find the amount of dots below 80. The high temperature was less than 80 degrees Fahrenheit on 20 days. Use the stem and leaf plot in example 4 to determine how many states had populations in which 14% or more people were at least 65 years old in 2010. Find the amount of leaves that represent a percentage of 14 or greater. You find that 16 states had populations in which 14% or more people were at least 65 years old in 2010. Construct a frequency distribution and histogram for the dataset in example 2. To construct a frequency distribution, first decide on the number of intervals. Because the least number is 64 and the greatest is 96, it seems that 8 intervals will be appropriate. The first interval would be 60 to 64, the second would be 65 to 69, and so on. By grouping the data into 8 intervals, you obtain the distribution shown. Create a histogram for the distribution. Find the mean, median, and mode of the following dataset. The mean is the average, so find the average of the dataset. Simplify the numerator. Simplify the fraction. You find that the mean is 75 and 8/10. The median is the middle number, so write the dataset in consecutive order. You find that the middle number is between 73 and 74, so find the average of the numbers. You find that the median is 73 and 5/10. The mode is the most repeated number. You see that 82 is the only number that occurs more than once, so the mode is 82. Which measure of central tendency is the most representative of the data shown in each frequency distribution? Part A. For this data, the mean is 5, the median is 5, and the mode is 5. So you find that all measures represent the data equally. Part B. For this data, the mean is 5 and 41 hundredths, the median is 5, and the mode is 9. Of these, the mean or median are representative of the data. Part C. For this data, the mean is 5, the median is 5, and the mode is 1 and 9. Of these, the mean or median are representative of the data. Part D. For this data, the mean is 8 and 90 hundredths, the median is 7, and the mode is 8. Of these, the mode is representative of the data. Consider the three frequency distributions represented by the histogram shown below. Which dataset has the least standard deviation? Which has the greatest? Of the three datasets, the numbers in dataset C are grouped more closely to the center, and the numbers in dataset B are most dispersed. So, the data in set C has the least standard deviation, and the data in set B has the greatest standard deviation. Find the standard deviation of each dataset shown in the checkpoint with example 3. Because of the symmetry about 4 in each histogram, each dataset has an x-bar of 4. To find the standard deviation, take the square root of 5 times the quantity 1 minus 4 squared plus 5 times the quantity 2 minus 4 squared plus 5 times the quantity 3 minus 4 squared plus 5 times the quantity 4 minus 4 squared plus 5 times the quantity 5 minus 4 squared plus 5 times the quantity 6 minus 4 squared plus 5 times the quantity 7 minus 4 squared, all divided by 35. The red numbers are the x, the blue numbers are the frequency that they appear, and the green number is the total amount of data points. Simplify the numerator. Simplify 5 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9. Simplify the fraction. Simplify the square root. You find that the standard deviation of dataset A is 2. To find the standard deviation of dataset B, take the square root of 5 times the quantity 1 minus 4 squared plus 3 times the quantity 2 minus 4 squared plus 3 times the quantity 3 minus 4 squared plus 1 times the quantity 4 minus 4 squared plus 3 times the quantity 5 minus 4 squared plus 3 times the quantity 6 minus 4 squared plus 5 times the quantity 7 minus 4 squared, all divided by 23. The red numbers are the x, the blue numbers are the frequency that they appear, and the green number is the total amount of data points. Simplify the numerator. Simplify 5 times the quantity 9 plus 9, and 3 times the quantity 4 plus 1 plus 1 plus 4. Simplify 90 plus 30. Use the calculator to approximate the square root of 120 divided by 23. You find that the standard deviation of dataset B is approximately 2 and 28/100ths. To find the standard deviation of dataset C, take the square root of 2 times the quantity 1 minus 4 squared plus 3 times the quantity 2 minus 4 squared plus 4 times the quantity 3 minus 4 squared plus 5 times the quantity 4 minus 4 squared plus 4 times the quantity 5 minus 4 squared, plus 3 times the quantity 6 minus 4 squared, plus 2 minus the quantity 7 minus 4 squared, all divided by 23. The red numbers are the x, the blue numbers are the frequency that they appear, and the green number is the total amount of data points. Simplify the numerator. Simplify 2 times the quantity 9 plus 9, 3 times the quantity 4 plus 4, and 4 times the quantity 1 plus 1. Simplify 32 plus 24 plus 4. Use the calculator to approximate the square root of 60 divided by 23. You find that the standard deviation of dataset C is approximately 1 and 72/100ths. Use the alternate formula for the standard deviation to find the standard deviation of the following set of numbers. Begin by finding the mean of the dataset, which is 4 and 6/10ths. To find the standard deviation, take the square root of the sum of the squares of the numbers in the dataset divided by the number of numbers in the dataset minus the square of the mean. Simplify 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and 4 and 6/10ths squared. Simplify the numerator. Simplify the fraction. Simplify 23 minus 21 and 16/100ths. Use the calculator to simplify the square root of 1 and 84/100ths. Round your answer to 2 decimal places. You find the standard deviation of the dataset is 1 and 36/100ths. In example 6, what percent of the data values lie within one standard deviation of the mean? To find the percentage of the data that lies within one standard deviation of the mean, find the interval that is one standard deviation above and below the mean. Find the lower limit by subtracting one standard deviation from the mean. You know that the mean is 27 and 4/10 and the standard deviation is 21 and 9/10. Simplify 27 and 4/10 minus 21 and 9/10. You find that the lower limit is 5 and 5/10. Find the upper limit by adding one standard deviation to the mean. Simplify 27 and 4/10 plus 21 and 9/10. You find that the upper limit is 49 and 3/10. The interval is 5 and 5/10 to 49 and 3/10. Count the amount of data values that do not lie within the interval and divide it by the amount of data values in the table. Simplify 10 divided by 51. Round your answer to 2 decimal places. You find the percent not within one standard deviation is 20%. Now subtract the not within percentage from 1. Simplify 1 minus 20/100. You find that 80% of the data values lie within one standard deviation. Find the lower and upper quartile for the following data set. Write the set in numerical order. You can find that the median of the entire set is 41. The median of the 6 numbers that are less than 41 is 23, so the lower quartile is 23. The median of the 6 numbers that are greater than 41 is 64 and 5/10, so the upper quartile is 64 and 5/10. Sketch a box and whisker plot for the data set 19, 22, 38, 44, 50, 54, 56, 62, 67, 79, 81, 85, 93. The data goes from 19 to 93. The median is 56. The lower quartile is 41. The upper quartile is 80. Complete the plot by drawing a box around the inner quartile range. A normal distribution has a mean, x-bar, and a standard deviation, sigma. For a randomly selected x value from the distribution, find the probability that x-bar minus sigma is less than or equal to x is less than or equal to x-bar plus 2 sigma. The probability that x-bar minus sigma is less than or equal to x is less than or equal to x-bar plus 2 sigma is the shaded area under the normal curve shown. Therefore, the probability is equal to 0 and 34/100 plus 0 and 34/100 plus 0 and 135 thousandths is equal to 815 thousandths, or 81 and 5/10%. The blood cholesterol readings for a group of women are normally distributed with a mean of 172 mg per deciliter and a standard deviation of 14 mg per deciliter. About what percent of the women have readings between 172 and 200 mg per deciliter? The readings from 172 to 200 mg per deciliter represent 2 sigma to the right of the mean. The probability between x-bar and x-bar plus 2 sigma is equal to 34/100 plus 135 thousandths is equal to 475 thousandths, which is 47 and 5/10%. Therefore, 47 and 5/10% of the women have readings between 172 and 200 mg per deciliter. Scientists conducted aerial surveys of a sea sanctuary and recorded the number x of seals that they observed during each survey. The number of seals observed were normally distributed with a mean of 73 and a standard deviation of 14 and 1/10. Find the probability that the scientists observed at most 90 seals during a survey. Begin by finding the z-score that corresponds to an x value of 90. Substitute 90 in for x 73 in for x bar, and 14 1/10 in for sigma. Simplify 90 minus 73. Simplify 17 divided by 14 1/10. You find that z is approximately equal to 1 2/10. You find that the probability that x is less than or equal to 90 is approximately equal to the probability that z is less than or equal to 1 2/10. Use the table to find the probability that z is less than or equal to 1 2/10. You find that the probability is 8,849 10,000ths. So the probability that scientists observed at most 90 seals is 88 49/100%. The table shows the shoe sizes x and the heights y in inches of 8 men. Find the sum of square differences for the linear model y star is equal to 1 87/100 x plus 51 2/10. Find y star by substituting the x values into the equation. Substitute in 8 5/10. You find that y star is equal to 67 95,000ths. Substitute in 9. You find that y star is equal to 68 300ths. Substituting 9 5/10. You find that y star is equal to 68 965,000ths. Substitute in 10. You find that y star is equal to 69 9/10. Substitute in 10 5/10. You find that y star is equal to 70 535,000ths. Substitute in 11. You find that y star is equal to 71 77/100ths. Substitute in 12. You find that y star is equal to 73 64/100ths. To find the y minus y star values, subtract the y star values from the y values. To find the value of y minus y star quantity squared, take the values from y minus y star and square them. Combine the values for y minus y star quantity squared to find the sum of differences. You find that the sum of differences for the linear model is 9 56,775 millionths. Find the least square regression line for the points -1, -1, 0, 0, 1, 2, and 2, 4. Create a table. You'll need the values for x, y, xy, and x squared. Write the x values of the points into the x column and the y values of the points into the y column. Simplify -1 times -1. Simplify -1 squared. Simplify 0 times 0. Simplify 0 squared. Simplify 1 times 2. Simplify 1 squared. Simplify 2 times 4. Simplify 2 squared. Sum the columns. The sum of the x column is 2. The sum of the y column is 5. The sum of the xy column is 11. And the sum of the x squared column is 6. For this table, n equals 4 because there are 4 points. To find the least squares regression line, use the formula below. Substitute 4 in for n, 2 in for the sum from I equals 1 to n of x sub I, 5 in for the sum from I equals 1 to n of y sub I, 11 in for the sum from I equals 1 to n of x sub I, y sub I, and 6 for the sum from I equals 1 to n of x sub I squared. Solve for a by using the method of elimination. Multiply the second equation by -2 and add. Divide both sides by -10. You find that a is equal to 17/10. Substitute 17/10 in for a in the first equation. Subtract 17/5 from both sides. Divide both sides by 4. You find that b equals 2/5. The least squares regression line is y equals 17/10 x plus 2/5. Find the correlation coefficient r for the data given in the checkpoint with example 2. How well does the linear model fit the data? Use the formula for R. Recall from checkpoint 2 that n equals 4, the sum of x sub I equals 2, the sum of y sub I equals 5, the sum of x sub I, y sub I equals 11, and the sum of x sub I squared equals 6. For this formula, you will need the sum of y sub I squared. Make a table for y and y squared. For y equals negative 1, y squared equals 1. For y equals 0, y squared equals 0. For y equals 2, y squared equals 4. And for y equals 4, y squared equals 16. Sum the y squared column. You find that the sum of y sub I squared is equal to 21. In the R equation, substitute 4 in for n, 2 in for the sum of x sub I, 5 in for the sum of y sub I, 11 in for the sum of x sub I, y sub I, 6 in for the sum of x sub I squared, and 21 in for the sum of y sub I squared. Simplify 4 times 11, 2 times 5, 4 times 6, 2 squared, 4 times 21, and 5 squared. Simplify 44 minus 10, 24 minus 4, and 84 minus 25. Simplify the square root of 20 times the square root of 59. Simplify 34 divided by 2 times the square root of 295. Use a calculator to find 17 divided by the square root of 295. Because 990 thousandths is close to 1, the linear model is a good fit for the data. Find the least squares regression parabola for the points negative 3, negative 2, negative 2, 0, negative 1, 1, and 1, 0. Create a table. You will need to know x, x squared, x cubed, x to the fourth, y, xy, and x squared y. Write the x values from the points into the x column and the y values of the points into the y column. Square the values in the x column and place them into the x squared column. Cube the values in the x column and place them into the x cubed column. Raise the values in the x column to the fourth and place them into the x to the fourth column. Multiply the x column by the y column and place them into the xy column. Multiply the x squared column and the y column and place them into the x squared y column. Sum the columns. The sum of the x column is negative 5, the sum of the x squared column is 15, the sum of the x cubed column is 36, the sum of the x to the fourth column is 99, the sum of the y column is negative 1, the sum of the xy column is 5, and the sum of the x squared y column is negative 17. For this question, n equals 4 because there are 4 points. Use the least squares regression parabola equations. Substitute 4 in for n, negative 5 in for the sum of x sub I, 15 in for the sum of x sub I squared, 36 in for the sum of x sub I cubed, 99 in for the sum of x sub I to the fourth, negative 1 in for the sum of y sub I, 5 in for the sum of x sub I, y sub I, and negative 17 in for the sum of x sub I squared, y sub I. Solve for a, b, and c. You find that a equals negative 1/2, b equals negative 1/2, and c equals 1. So the least squares regression parabola is y equals negative 1/2 x squared minus 1/2 x plus 1.